Hello everyone. In the last video we have discussed about reversible gate, irreversible gate, Toffoli gate, and we were left with the topic of how we can make any irreversible gate as a reversible gate. So today we will continue the fourth subtopic and finish it. So I will continue it in the same page. So our fourth topic is making irreversible gate as reversible. Reversible. So in the above example of Toffoli, we were what we were basically doing. We were zoring it. Means we were attaching a zor gate to make it reversible. So this is done everywhere. So we can use same method of zoring to make any irreversible gate as reversible gate. So suppose if we are having a gate, we don't know what gate it is, so it is just a gate. We are having an input of A, B, and output is just, since we don't know what gate we are utilizing, so it will be a function of A and B. So suppose if it is a AND gate, suppose if this is a AND gate, then what will be our function of A? Suppose A is 0, B is 0, function of A 0 0 will be 0, F 0 1 will be 0, F 1 0 will be 0, F 1 1 will be, sorry, this will be 1. Okay, so these types of gate are irreversible. Why? Because we know that for any gate to be reversible, the number of input should be equal to number of output, and here we are having very few output since we are having only one output and we are having two input. So this can't be the first possibility is itself not satisfied. First criteria itself is not satisfying, so we can say that this is a irreversible gate. So how we can make this irreversible gate as a reversible gate? We will introduce a third input as C, where we will XOR it, means where we will XOR this gate. So before adding the XOR gate, let's understand, means what are the effect of XOR on any output function. Okay, so suppose we are having a function f of a and b. Okay, and we are having a XOR operation done on C. So what are the possibilities of C? Either 0 or 1. So if we imply with 0, then what it will become? This is the question we should look at. Suppose for the AND gate itself, if we are talking about AND gate itself, so suppose if we are taking F0 0 XORing it with 0. So what we are getting? F00 is 0, 0 and 0 is again what? It is 0. So we know that 0 is F00, so we can easily say that F XOR 00 XOR means F00 XOR 0 is again the same function, right? Now let's look at the other example. 1 0 and this will be XOR 1. So what here it will become? So no, so let's not take the opposite. Let's take the same example. Suppose F00 XOR 1. So what will be its effect? So F00 we know it is 0. 0 XOR 1 is what? 1. So 1 is basically what? So F00 is 0 and opposite of 0 is 1. So we can say that it is equivalent to F00 flip, right? So from here we can conclude that if there is a function of a and b and we are applying means we are zoring it with 0, then it will give us same result. And if we are zoring it with 1, then it will give the flip of that result. So this is one thing you can test for other gate also. It will work perfectly fine with OR gate and all. Function result will be same. So now look back. We are having this gate. Let's apply XOR operation. So we are having this gate. Okay. And we are having function of A and B. Okay. This is A, this is B. Now what we will do is we will introduce a third C and we will apply a OR operation means or not XOR operation and it will be equivalent to A B XOR C and we will be taking this A as usual and B here. So now we will be having 3 input and 3 output. So now let's write the truth table. How the truth table of this particular reversible gate will look like. So let's start with A, B, C and now output side will be A, B, function of A and B XOR with C. Now suppose this is 0, 0, 0, 0, 0, 1. Let's write all possible combination 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. Have we written all the possible combination? Yeah. Now let's apply the function, how the function will look like. So here it will be same. Let's again write it like, oh, let's write one by one. Since this is 0 0, so it will be f 0 0 XOR with 0. So from the above example, what we see, if we are XORing it with 0, we are getting the same function. So it will be equivalent to f 0 0. So from here we can say wherever it is XORing with 0, there we will get the same function of a and b, f, and where it is joining with 1, we will get the flip of that. So let me quickly write here, we are joining it with 1, so we will be getting the flip, right? In the third case we are joining it with 0, so we will get the same function. Here we are again joining it with 1, so let's flip it. Here we are XORing it with 0, so it will be same function. Here we are XORing it with 1, so it will be flip. And here it will be same function, and after that here it will be flip. Correct? So this is the truth table of two main input, and the third we have added input, and based on this it is the truth table of the reversible gate. So you can just replace this gate with AND gate and apply those logic directly. It will work perfectly. So this is all about the reversing of gate. You can reverse. So this is based on the only one gate. Suppose there might be a case where we are having multiple. Suppose there is a case where we are having input as A and B. Okay, now what is happening is we are having gate and it is giving two types. Both have the input pin as means equal input and output pin, but it is giving as a function of f and b, a and b, and this is giving as g, a and b, like two different functions they are returning. So there is a huge possibility that both of them have the equal number of input and output. So possibility is there that it is reversible, but not always. We have already studied in the previous video that it should be having the distinct input and output and have one on one matching. Like so, if let's assume for now that this is not means this is a irreversible gate. Currently this is not a reversible gate. So in this case what we can do, basically we know that we will be introducing one extra input for our operation on C, means on for operation or for addition of XOR. So simply this is A, this is B, and here we are having the gate, and let me color it like this. So this is our function of A and B, which will be moving to a XOR gate. Oh sorry, let me draw it properly. So which will be moving to XOR gate, and there will be a C. Correct? So this will be returning as function of A and B, and we will be having the XOR operation with 3. Correct? And for the second case, let me color code as G of AB. We will again have a XOR operation and another input of D, which will be having G of A and B XOR D, and our this A will be there and this B will be there. So now we are having input as A, B, C, D and output as AB, function of AB is or C, function of G, A, B is or D. So can we write a truth table of this? Definitely a slightly longer truth table but worth writing. A, B, C, D. Our output will be looking like A, B, and function of A and B XOR C. Let me slightly function of G of A, B XOR D. Okay, so we already have understanding of XORing with 0 and 1. Okay, so wherever it is 0, it will return the same function, else it will flip. So we will quickly write all the possible combination. Okay, there will be 16 combination, right? Because we are having 4 and we know that we will be utilizing 2 to the power 4. So like that. So 0 0 0 0 0 0 1 0 0 1 and 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1. Okay, wait a second. 1 0 0 1 1 1 till 7 we have written, right? Means 1 2 3 4 5 6 7 8. Total 8 combination we have written. There is one quick way to writing also, but let's write it. Now we can write it like this. Now we can put 1 1 1 1 1 1 8 time 1 2 3 4 5 6 7 8. Like this we can write. It is just a quick way. I have already told in my previous video also. Now next will be 0 0 0 0 1 1 1 1. Now next will be 0 0 1 1 0 0 1 1. Now next will be 0 1 0 1 0 1 0 1. It is just a quicker way of writing, else you can write it like anyway. I have already told you in my earlier video of how to write quickly all the possible combination. So again, let's start writing. This is 0, this is 0, and since A, B and C is 0, so it will be AB, same function, and G of AB and XOR is 0, so it will be again this. Oh, sorry, let me not write AB, instead we should write it like it we have input, right? So yeah, so it will be like this. And I hope so you can easily feel all other, because and here it is 1, so it will be again like flipping. So you can feel it quickly, and so this will work like this. So I hope I have filled the first 4. You can fill the rest one. It will be quicker only. So I will fill it quickly. Means you can also try it. Yeah, I hope you got the understanding of how XOR of 0 and 1 are working with the function. So let me quickly fill it. 0, 1, and okay, this will be, we are here, right? So Z of 0, 1, 0, 1, F of 0, 1, Z of 0, 1 flip, and this will be 0, 1, F of 0, 1 flip, G of 0, 1. And I hope everything is getting right, because I am doing it very quickly and hope there should be no mistake. 1, 0, F of 1, 0, and it is not flipping. G of 1, 0, no flip. 1, 0, F of 1, 0, G of 1, 0 will be flipping, and here it is 1, 0, F of 1, 0 will flip, and G of 1, 0 will not flip. Instead of comma writing, you can understand it. 1, 0, both of them will be flipping. 1, 0, both will be flipping. This is 1, 1. So f of 1, 1 will not flip, g of 1, 1 will not flip, and here this will not flip, this will flip. Here this is going to flip, this is not going to flip. Here uh, both of them are going to flip. So I hope with this truth table you get an understanding of how if there are two output, two function, and still it is irreversible, then how to make them reversible. So this is a quicker thing. Now suppose I am giving you a question. Suppose or what? This is not a suppose thing. I am giving you a question. You have to solve this question and check whether that particular gate is irreversible or not. If it is irreversible, make it reversible and write its truth table. You can write it, means you can mail me your answer. I hope it is there in the description itself. It is very simple, quantumwithneel@gmail.com. So there you can write. Means there you can mail your question. I can check and we can communicate there also. So you can get my mail mail from the about section of YouTube. So from there. So let's have, suppose this is one gate. Let's name it as Neel gate, and it is one input, and A, B, and let it to be two input gate. Then only you will be checking, else you will simply say, oh, it is irreversible gate. A, B. So there is a function of A and B, and there is a function of g of a and b. Okay, now what function of a and b are? Function of 0 0 is 1, function of 0 1 is 0, function of 1 0 is 0, function of 1 1 is 1. Okay, so and our second is function of g 0 0 is 0, means this 0 1 is 1, 1 0 is 1, and 1 1 is 1. So use this logic and tell me whether this gate is reversible or irreversible. You can comment out whether it is reversible, irreversible, and then you can send me the truth table in the mail itself. I can check and reply there also. So based on how many response I am getting, so I will write whether this Neel gate is reversible or irreversible. If it is reversible, then nothing, no need to do that. And if it is irreversible, then you have to make a truth table of it and just write below that it is irreversible. In the next video, we will do the solution video. Means that will not be a video of this part. I will make a separate video on the solution of this particular question. Okay. So I hope you understand on how we can make any gate as reversible, any irreversible gate as reversible. So in the next video, means in the next video of this series, we will look at error and how error came in our system and how we detect that error and how we solve that error. So we will look it in the next video. So I hope if you are new to my channel and if you are continue following this video, then you can definitely subscribe it if it worth, if this video worth it. So if you like the video, then you can thumbs up, thumbs the like button, press the like button, and if you have get nothing from this video, you can press dislike, and it will definitely help me to improve my videos. And you can write comment on the solution of this particular question. So meet you in the next video. Thank you.